Homework number 8. In the first section, you're asked to complete the table of values and graph the equation shown. Remember, in this equation, the input, which erases and replaces the letter x, is to be multiplied by -2 and then subtract 1. So every time we put in the value we are given, we will multiply by -2 and subtract 1. So this outline can be used for every single input. We're going to multiply by 2 and then subtract 1. So the first value I'm going to substitute is -2. And when I substitute -2, I get -2 times -2, which is +4. +4 minus 1 is 3, leaving me with the point -2, 3. That pair of values makes the equation true. So I'm going to go ahead and fill in all the rest of the substitution values and compute. -2 times -1 is 2 minus 1, giving me the point -1, 1. Now that I have all of my ordered pairs, I can start graphing them on this coordinate plane. So again, I'm going to start with my first coordinate here, -2, +3. -1, 1, 0, -1, 1, -3, and 2, -5. If you do it correctly, it should create a long straight line. The second section asks you to identify the rate of change, or the slope, as well as the y-intercept if you're only given an equation. In an equation that is written in this format, y equals mx plus b, where y is alone and x and a constant are on the other side, then the coefficient of x is the slope, and the constant is always the y-intercept. So if I know in my first equation that the coefficient of x is 4, then the slope is 4. Notice I do not write the letter x. I just write the 4. X is located next to the slope. It is not part of the slope. And the constant at the end is +3. In the next question, the coefficient of x is a fraction, so the rate of change, or slope, is 2/3. This time the y-intercept has a subtraction sign in front of it, and that becomes the sign of the number. The y-intercept is -7. For the next example, our coefficient is invisible, and the only invisible coefficient is 1. So the rate of change is 1, and the y-intercept is +7. For this last question, you're asked to describe how you were able to do that. Describe in words where you looked to identify the slope when all you are given is a linear equation. Notice it's not asking me about the y-intercept, it's only asking me about the slope, or the rate of change. So where did I look? So when it's in this format, right, when written as y equals mx plus b, the coefficient of x is the slope. You can write slope, or you can write rate of change. I'll put ROC for that. And if you can't remember the word coefficient, you can simply say the m value. The m value is the slope, or rate of change. For this next section, you're asked to create that y equals mx plus b sentence yourself, by placing the m value as the coefficient and the b value as the constant, or the slope value as the coefficient of x and the y-intercept value as the b constant. So in the first example here, the m value is -5/3, don't forget the x. The b value is -2. For number 6, the m value is 7, don't forget the x. The b value is +3. So you have to write that positive sign yourself. For number 7, the rate of change or coefficient of x is -8, the y-intercept is +5. And for the last one, don't get tricked. The y-intercept is 4, and the slope is -2, so you have to put them in the right order. If the y-intercept is 4, that would go at the end. And if the coefficient of x is -2, that would go in the beginning. So -2x, and then the +4. You could also write the +4 first, as long as you don't put an x with it. And then you could write your subtraction 2x second. This is also correct. For this next section, you have to find the slope yourself. We do that by determining the change along the y-axis and the change along the x-axis, pronounced delta y and delta x. Some people refer to it as rise over run. So I'm going to find my perfect 2 corner points, and then I'm going to change along the y-axis. That means I'm going to rise along the grid lines. And then I'm going to count these boxes. So from -4 to +3 is an increase of 7. And now I'm going to run or change along the x-axis, and then I'll count those boxes. From -3 to +2 is an increase of 5. So for us, our slope fraction will be 7/5. Notice when I draw my slope triangle that I can only draw along the grid lines, forming that perfect 90-degree slope triangle. Again, for number 10, when I drew my rise, I went from +2 down to -3. That's a decrease of 5, so you need a negative value, as you can see, because the line is going downhill. And if you go downhill, your fraction should be negative. Now when I run across here or change my x, delta x, I go from -3 to +1, which is a change of 4. So my fraction will be -5/4. For my last line here, when I change along the y-axis, I have an increase from -4 to 2, which is a +6. And then when I change along my x-axis, my run, I have an increase of 2. You could write the fraction as 6/2. You could reduce the fraction, to 3/1, or you could simplify it all the way just to 3. For the next lesson, we're going to use our inverse operations to isolate the variable x. So when I look at this sentence, I see that my right side has more terms. So that's the side I should focus on. On the right side, I have a variable and a constant. On the left side, I just have variables. So I would like to combine these, but I cannot if they're on different sides. So I'm going to subtract 6x from both sides so that I can now combine like terms. Don't forget to bring down that negative sign. Divide by your coefficient, and there's your solution. You can always do a check step by erasing and replacing your x's with the value you determined. Once you compute, you should have matching terms. -40 equals -40 is true. For number 13, I'm going to add 7x to both sides because I want to keep my x positive. And so even though it's on the right-hand side, I like that it's positive. Now I'm going to subtract 29 from both sides, giving me a -26 equals 13x. When I go to divide, I divide by the coefficient, not the number on the left, but the coefficient. So that leaves me with x equals -2. For number 14, the left side has more terms, so that's the side I can choose from. And since the right side has variable terms, that means I want to move my variable term. So I'm going to subtract 4x from both sides, leaving me with 5 equals 2x. And when I divide both sides by 2, I can either leave it in fraction form, or I can change it to a decimal if it terminates. That means if the decimal doesn't repeat or go on forever. For question number 15, after I subtract 6 from both sides, I'm left with a fraction as my coefficient. And to clear a fraction that's a coefficient, you multiply by the reciprocal, or you flip it over. So I'm going to multiply both sides by 5/2, leaving me with f equals negative 35. For number 16, I'm going to subtract 3r first. And now I can subtract 4. When I divide by my coefficient, I get my final value of negative 11. For number 17, be careful on your second move here. When you rewrite, you'll notice that x is already being divided. So the inverse of dividing is not dividing. The inverse of dividing is multiplying. So we're going to multiply both sides by 3, leaving us with x equals negative 18. For the next example, you'll notice that my left-hand side has 3 terms. The most you're allowed to have is 2. So that means that I can combine these terms, not use an inverse operation. When I combine 9x and minus 5x, I get 4x. And I'm subtracting because that's what it says in front of the 5. It says minus 5x. Now, when I use my inverse operations and I subtract 4x from both sides, I'm going to get 12 is equal to 12x minus 12. That's a lot of 12s. But when I add 12 to both sides, the left side becomes a 24. And when I divide by my coefficient, I get my final answer of x equals 2. Again, for the next question, I have 3 terms on one side. The most you can have is 2. So I'm going to combine like terms here. I'm going to leave the left side exactly how it is. 4x's minus 7x's is negative 3x's. Now you may notice something already. My left side and my right side have matching variable terms. And anytime that happens, we know we've got a special solution. Now which one we have depends on the constants. If the constants are the same, that would be infinite. But in our case, the constants are different. So that means that we have no solution. Matching variable terms with different constants results in no solution. And this is why. If I were to add 3x to both sides, my x's would entirely disappear. And the sentence that would remain would be false. 7 can never be equal to negative 18. That's why there are no solutions. In my last example, you may notice I start with a similar pattern. I have matching variable terms, but this time I also have matching constants, and that means the left side and the right side are a perfect match. You see it? Infinite solutions. And the proof is, when I add 9x to both sides, and my x's entirely disappear, my remaining statement is true. And that concludes homework number 8.